Join us on an investigative journey as we educate each other on a scientific discovery, concept, or phenomenon.
Then we'll take a dive into the complicated and misleading world of pseudoscience to sort the factual from the fabricated.
I'm Matt McCabe.
I'm Levi Bateman.
And I'm Dr. Sam Laucirica.
And this is Idiofacto.
Righto, mate. I didn't introduce myself as Forrester Levi Bateman.
Hey, is that part of your actual title?
I'm biologist Matt McCabe.
Yeah, there you go. Nothing wrong with that.
It's probably not really all that relevant to the episode. I mean, we did request that you come.
I mean, the doctor is a relevant one to this one.
Yeah, no, it is.
I don't usually do it. just to random people I meet on the street.
Bet you're fun at parties.
Yeah. Oh, yeah.
This is my friend Levi, this is my friend Tom, and this is my friend Dr. Sam Laucirica.
Yep. Thank you. MD, if you don't mind after that.
Oh, okay.
MBBS.
No, I'm not even MBBS, actually. I'm an MD.
Oh, really?
Yep.
What's the difference?
MBBS is Bachelor of Medicine, Bachelor of Surgery. MD is Doctor of Medicine. It's just essentially that the degree contains a research component.
I have a fun oral game that we can play, boys.
Let's do
Okay,
it.
go on.
Would you like to play an oral game?
I would like it better if you didn't say it like that.
Yeah.
How about I call it a sound game? Do you want to play a
I like
sound
that.
game?
That's good.
Yeah, sound games.
All
Yeah,
right.
let's play a sound game.
I have in front of me some snacks, and I'm gonna eat some of the snacks, and you've got to guess what they are. Sound alright?
Okay.
Yep.
Trust me, when I get to the punchline.
Ladies and gentlemen, today's episode is on coronavirus. And I'm sure this is going to be relevant somehow.
The punchline is much more interesting. It's actually not related whatsoever to the topic, but I just thought it'd be a fun little game. I just want to share it with everybody.
Okay, fair, go. It's a sound game. Let's do it.
Here's the snacks in a brown paper bag.
Can I guess now?
Yep, go.
Wasabi peas.
Not wasabi peas. I also have those in front of me, but
Alright.
I intentionally told you that before we came on air so that you'd guess that. So now you look like a fool.
I do.
All right, here we go. I've got some in my hand. I'll put them in my mouth. Ready? Can you hear me crunching them?
Yes.
Yes. Right in my ear holes.
What do you think that snack sounded like?
What did you think? It sounded like some chips to me, but...
Chips? Yeah.
Is that what it was?
Sam, any guesses?
Chips. I'm with Matt on that one. You know, this is a much less exciting game than I thought.
Yeah, I was
Wow.
expecting something revelatory.
It's about to get a whole lot more exciting. They're not chips, but they certainly are crisp. They are dried and roasted crickets.
Ah.
Oh.
I couldn't hear the screams though.
Well, that's because they screamed long ago.
Ah, okay.
Yeah. They were put in an oven and dried.
When they did scream, it was more like, Huzzah!
What? Huh?
Wow. Pity laugh and a half there.
Oh.
Well, I didn't even laugh. I didn't even get it.
That's because you're stupid.
Oh, God.
This is taking a real strange turn.
It really has. Let's move
This
on.
isn't what I prepped for.
I got some crickets. I got some crickets for some snacks from a shop that sells totally unpackaged food. And I got a little paper bag full of crickets because I wanted to try them. And they taste like a cross between popcorn and peanuts.
That's not what I expected they would taste like.
No, they're pretty good. They're a pretty tasty little snack.
I thought they would just be like little protein crunches.
Well, they're like almost 70% protein.
Yeah, it's actually really good for you.
Yeah.
No fat and a lot of protein.
Yeah. Full of vitamins.
It's the way of the future.
Yeah, it would be if they weren't so damn expensive.
Oh, really?
It's about $250 a kilo.
Oh, what?
What?
Which is why
I mean, I guess they're not readily available in Australia, are they? You know where they are readily available, though?
Where?
China.
Right. Yeah.
Mm.
Is there some kind of segue that you're trying to get at?
Yeah, a little bit, yeah.
What else is
Let's
readily
move on
available
from
in
the sound
China,
game.
What else is readily available in
No,
China?
Levi, No, you take it away from here.
All right, thank you for that wonderful segue.
You're welcome.
In case you haven't guessed, and you would already know by now, this week, on our first episode back for about 4 months, We're going to be talking about coronavirus, which is one of the things that's been keeping us from recording an episode because the world has been plunged into absolute madness by this coronavirus that we now know as SARS-CoV-2, and it's changed the way that we do almost everything in life. So we figured that it was a good time to jump on, have a bit of a chat about viruses in general, what they are, what the coronavirus is, and maybe, of course, because this is ideo facto, some of the pseudoscience and the myths that are coming out surrounding this whole coronavirus pandemic. Matt's going to be covering that. Soaked in sarcasm, I'm sure.
I have never been sarcastic in my entire life. Not a single time.
Was that sarcasm?
Gotcha.
We're pretty rusty, I think.
My jokes haven't gotten any better, that's for sure.
This is the longest that we've had off since we began. So anyway, I might kick off by just having a bit of a chat about what a virus actually is, because it's quite an unusual one. If you listen to some of our earlier episodes on biological kingdoms, you remember a discussion that we had about viruses and the fact that it's a bit of a contentious issue. They're sort of not entirely living. A virus, and there's arguments either way. Some would argue that they are a living organism, and others would argue that they're not. I can understand the argument for both. So they do have genetic material, which is why some would believe that this would make them living. But they also lack a cell structure that would be typical of a living thing, and they also lack the ability to replicate on their own outside of a host. So viruses differ greatly in size and shape, but they all sort of have the same basic structure. I learned that the most common virus that you've probably seen drawn, and when you see a picture of a virus, it's most likely a bacteriophage, which is, as the name suggests, a virus that infects bacterial cells. This is the one that looks like a bit like a spider with the legs that sort of come out and grip onto the cell, and the pod that's full of genetic material, and sort of a little syringe that injects the DNA or the RNA.
Like a head crab looking thing.
Like a head crab, yeah. Shout out to all the Half-Life fans.
And sorry to my brother who's specifically scared of head crabs at the moment after playing Half-Life Alyx. So
in virtual reality.
Yes, in virtual reality.
And I can imagine that would be terrifying.
The only way to play, apparently.
Apparently. I can think of a few other ways. One being not in virtual reality.
The only way to play.
All right. So the first thing that I've got to point out about viruses is that they're actually much smaller than bacteria. So they range from about 20 nanometers to 300 nanometers. And that doesn't mean anything if you don't know what a nanometer is, but there are 1 million nanometers in a millimeter. So bacteria are anywhere from 1,000 nanometers to 10,000 nanometers. So a human red blood cell is about 10,000 nanometers in diameter. So for a virus, it's about 20 to 300 nanometers. That's much smaller. And the largest virus is still far smaller than the smallest bacteria. So you can generally only see a virus with a very powerful electron microscope.
They don't need to be very big because they're not very complex, are they?
Exactly, yeah. They don't need to be big to do their job. They don't have organelles or anything. They're just a packaged piece of RNA. So all viruses have this genetic material inside them. It's either RNA or DNA. And if you remember DNA, it looks like a twisted ladder. RNA is just one half of that ladder. So it's a half a rung, as the ladder goes up. Looks like it's been sliced in half. So it's the genetic material that's packaged inside a protein layer. It's called a capsid. Some viruses, but not all of them, and at different stages of life, might have an envelope of lipids on their structure, which is usually derived from the host cell membrane. And I learnt this, a whole virus in its full structure is called a virion, which is what you'd call the virus before it's injected its genetic material into the cell. So if you were to find one sitting on a surface somewhere, it's called a virion. So essentially, they're just a very small blob of genetic material wrapped up in a protein wrapper is all they are. So it's easy to see the school of thought and to understand why some people do believe that they're not at all a living thing, and instead just a collection of organic chemicals.
And again, I think it illustrates the problem that we have as humans with continua. They sit on a part of the continuum of life where it has aspects of life but is is not actually really life by our definition, but our definition is flawed because it leaves out some characteristics of like porifera or sponges, sea sponges. But it also, sea sponges have some exceptions to that rule, and there's exceptions all over the place, which is, it's just my long way of saying that our definition of life is an arbitrary one anyway. So whether or not viruses are life is kind of irrelevant. They are viruses. That's what they are.
Yeah, exactly right. And I mean, not even all bacteria fit the definition that they're able to replicate outside of a host. Like the bacteria that causes rickets and chlamydia aren't able to replicate outside of a host, but they're still considered a living organism. So you're totally right when we set a continuum and it doesn't quite work, and when the rules don't fit everything that gets discovered, we have a really hard time wrapping our heads around that. But I suppose a bacteria is a collection of chemicals that is right on the edge of life, and the genetic material is, I suppose, a marker that it's so close to being alive. So as I've said, viruses can't replicate on their own like bacteria, and they don't have any organelles, they don't have a metabolism or an energy structure, so they just kind of exist until they enter an organism. And viruses usually have a very specific type of cell that they interact with, and they're only allowed to do this because of their external structure, the capsid. So to better explain what this means, I'll run you through the 6 stages of a virus's life cycle, if we wanted to call it a life cycle. And these 6 stages are attachment, penetration, uncoating, replication, assembly, and the nasty one, which is release. So, attachment. Most of these are fairly self-explanatory, but attachment is the bonding between the capsid proteins on the outside of the virus and these very specific receptors on the host cell surface. And this is the reason why most viruses aren't actually able to infect a vast range of host cells. They're usually specifically targeted at a certain type of cell because that cell will have a specific receptor on it that the capsid proteins on the outside of the virus are able to bond to. So the next step is penetration, and this shortly follows attachment. And it involves a process called endocytosis or membrane fusion, whereby the virus actually enters the cell. So some viruses have evolved to inject their genome inside the host cell, and this leaves the capsid on the outside. And this is the image that we see of the bacteriophage virus, where that spider-looking thing, the head crab, where this little crab spider-looking thing comes down, clamps onto a cell, and then injects its genetic material into the bacteria. So after this process of endocytosis, so after penetration, comes uncoating. And fairly obviously, this is where the capsid, or the protein layer on the outside of the virus, is removed. And this is done either by enzymes inside the host cell or just by disassociation. So once it's attached, penetrated, and it's uncoated, then replication can begin. So replication of both the virus genome and later on the virion proteins. So you remember that I said that the virion has a capsid around it. This is made of proteins. And so the cell actually replicates these proteins. So it's actually quite fascinating, as devastating as it can be to some organisms. Once the virus is inside the cell, and once its genetic information is inside the cell essentially becomes a factory that reproduces the virus. So the virus, this genetic material, it's a set of instructions on how to build another virus, essentially. That's all it is. So it goes into a cell, and the cell is designed to produce proteins and to replicate genetic material. So the ribosomes within a cell will get to work, and they'll see the viral genome, and they'll just get to work replicating it. And they'll replicate it and replicate it. And when there's an instruction that tells it to build a protein to put on the outside of the virus, the capsid, it'll build the capsid protein, and it'll just keep building these virus parts. And it doesn't know that this is going to be incredibly bad for it. It just does it because that's its job.
All of these things sound like, when we're describing it, it sounds like we're giving agency to the virus and to the cells that the virus infects. But all of this is like a chemical process. It's not there's no direction, there's no there's consciousness of what is going on by either the virus or the cell. It's just a chemical process.
Yeah,
right?
exactly right. And the same thing would happen, I suppose, if you put these two different chemicals, or if you put a ribosome and RNA from a virus into a petri dish, essentially, to simplify it right down. It's just a chemical reaction. And I think we said the same thing in the CRISPR episode. It's the same as if you were to react bicarb soda with vinegar. A reaction takes place, and like you just said, the ribosome, which is an organelle inside a cell, it doesn't have agency. It doesn't know whether it's producing viral genetic material or its own genetic material. It just receives genetic material and it starts to reproduce it because that's its purpose. And it doesn't have agency. It's just a protein. It's just an organelle that's doing its job. And so if a cell couldn't do this, we'd be safe from viruses, but we also wouldn't exist because a cell needs to be able to replicate genetic material and to produce proteins based on the instructions in that genetic material. So a ribosome is just doing its job.
Yep.
So once all of the proteins, essentially the body parts for the virus have been built, then there's the assembly stage. And you guessed it, this is just building a virus. It's just the cell using its virus production line at this stage just to put all the bits and pieces together and to build a virus. So then the virus is whole and it just exists inside that cell. And the cell, by this stage, is full of virus DNA or RNA, and it's just replicating and building viruses, and it becomes so full of virus that eventually the cell membrane will burst. So this is the release stage of a virus's life cycle. So the virus is released from the cell, and of course this kills the cell. The cell can't exist if its cell membrane has been ruptured. Everything will come out. So this is mainly, but not only, through the lytic cycle. This is the most common one, where the cell will build so many viruses that it'll get full of virus and the cell will lyse, which means to break or to burst. And this will release all of the new virions into the body or onto the surrounding cells. So this is obviously pretty bad news, because now you've got these bodily cells that are basically a virus producing factory. They're just making more and more of the virus. And each time one of these cells bursts, suddenly there's hundreds, thousands more virions inside the body that all then enter another cell, and the cycle continues. So this is very bad news for the cells that the virus has been living in, but it's also very bad news for the multicellular organism that those cells are making up. So I can try and sum this part up, but I'll probably just throw it over to Sam about why a virus is actually bad for our body. I mean, it seems obvious because the cells will keep producing viruses, they'll burst, and it'll just keep destroying cells. But this isn't what happens until there's no cells left. Eventually, our immune system will kick in and it'll realize that something's wrong. Isn't that right? It'll come down, but in part, it's actually our immune system that's sort of making us sick. So do you want to quickly run through what happens with our body's immune system when we're sick with a virus?
Yeah, so essentially there's kind of two phases to the immune response. There's the initial phase, which is not targeted to the specific cause of the infection, and then the second phase is a targeted response. But basically the immune system can recognize proteins that are not part of the body, or in more general terms will recognize either unwell cells or proteins that are not part of the body, and will then attack them. So while that side of it's good, as any sort of immune response causes lots of inflammation, causes lots of fluid and edema, and causes lots of waste products from breaking down cells or from killing cells, causes lots of called cytokines, which are little markers, inflammatory markers that ramp up that immune response. So the issue then is, one, the virus is killing the tissue. Two, the immune system is attacking infected cells. And three, there's a big immune response which is causing disruption to the normal tissue function. So, well, that's the reason that it causes damage to the cells. It causes disruption to normal function.
Right, and I guess in that process, so while the immune system is running hot and trying to get rid of this virus, it's also using a huge amount of resources, isn't it?
Yeah.
So everything that you're putting into the body is being used up just trying to fight this virus, which I suppose is why with most viruses you feel so run down and like you've got no energy. Is it pretty safe to say that's the reason why? Because our own immune system is making us feeling run down?
Yeah, the issue is the foreign DNA and RNA and proteins which need to be removed from your body. But the actual symptoms are caused by the immune response.
Okay, but I guess it's helpful to note that we actually need these symptoms, and while that's the most unpleasant part about having some sort of virus, if we didn't have the symptoms, it would mean that our immune system isn't working.
Yeah.
Okay, so do you want to run us through what specifically coronavirus does to our body once it's entered our body, and which part of the body it affects?
Well, essentially, it's a respiratory illness, so it targets respiratory tissue, which, as you said before, because viruses they don't really have choices of what tissues they attack. They have one sort of protein that will attach to another sort of protein. So they target one type of tissue, essentially. So it targets respiratory tissue, and it causes disruption to the normal function of the tissue. So it causes that sort of destruction to the respiratory tissue where there's breakdown of the normal cell function, there's inflammatory responses there, and then you can't get rid of the waste products quick enough and can't get rid of that fluid. So that causes this respiratory illness that you get.
Which is basically pneumonia, right?
Yeah, it is. Yeah.
Well, that's a pretty good summary, I suppose, of viruses and a bit of background about how viruses work and what they do in the human body. Let's have a bit of a chat now about practical healthcare and what the coronavirus means for the healthcare system and what it shouldn't mean if you're trying to avoid it, if you get what I'm throwing to you.
Yes, I see what you're saying. I'll start by, we probably need to put some definitions down because there's a lot of terms going around in the media at the moment about COVID-19. So the current coronavirus pandemic is caused by a virus which is known as SARS-CoV-2, which just means severe acute respiratory syndrome coronavirus 2. So I think it's important to acknowledge the distinction between the term coronavirus, COVID-19 and SARS-CoV-2 because they're all kind of used interchangeably in the media. So let's start with coronavirus. Like you said, Lev, there are many types of coronaviruses. Coronavirus is named for the Latin corona, which means crown or wreath, and it was coined because of the appearance of the virus. It doesn't look like a head crab. It's a spherical shape that has like a fringe of little protein projections around it. So it kind of looks like a crown. So they called it crown virus or coronavirus.
I heard a physician say that often it's called a coronavirus and coronaviruses are named corona like the crown because often when you look at a virus, it'll be sliced into almost thin little biscuits. So when you look at it in an electron microscope, it's a cross-section which will be a round circle with some almost like points of the crown coming out of the outside. So it sort of does look like a crown.
Pretty much. It basically looks like if you had a metal sphere that somebody had shot with a whole bunch of Nerf darts. That's pretty much what it looks like. So coronaviruses range from the common cold to SARS-CoV-1, which was the first SARS coronavirus in 2003, and they mostly cause disease in mammals and birds. SARS-CoV-2, which is the current virus, is a strain of a coronavirus that can cause severe acute respiratory syndrome in humans. And it's the second virus that has been prevalent enough to be given the name SARS-CoV, and that's where the 2 comes from.
Mm-hmm. Another big coronavirus was MERS.
MERS, yeah.
If you remember that one as well.
It's the Middle East respiratory syndrome.
Yeah.
When was that around?
2012, I think.
Yeah, 2012, you're right.
Was it that recent? It had a really high mortality rate, didn't it?
It had a very high mortality rate. Yeah, so the death rate was 35%.
Wow.
Yeah, that's pretty high. So if you got it, you had a 35% chance of it being fatal.
Yeah.
So why does the mortality rate of different coronaviruses differ?
Mate, I don't know.
Yeah, I couldn't tell you that.
Sick. Thank you for joining us.
If we knew that, I think we'd be able to treat it a lot easier.
Right, okay.
So this virus, SARS-CoV-2, causes a disease. It's a respiratory disease that has been coined COVID-19, which is a contraction of coronavirus disease 2019. Basically, to reiterate, coronaviruses are a family of lots of viruses that have been around for a long time. SARS-CoV-2 is the current virus, and it causes a pandemic of a disease that we've called COVID-19. Just so that's absolutely clear, if you hear those interchangeably, you know what they're referring to. It's not known for certain exactly how SARS-CoV-2 first came to infect humans, but there's a number of theories.
Some dude ate a bat. That's
Yep.
definitely how it came around. So I heard someone on the internet say that some guy ate some bat soup.
Well, some theories are significantly more credible than others. The ones I've heard include that one about the guy eating bat, but the ones that people seem to take seriously are that, number one, it's a natural transmission caused by an interaction of some description between humans and an animal. And like you said, for some reason people think that some guy ate a bat and that was how it was caused, but there's no evidence to say that that's actually where it started. And concerningly, number two, a Pew survey report from the 8th of April this year suggested that about 30% of Americans believe that SARS-CoV-2 was created in a lab and either released intentionally or accidentally. 30% of Americans.
30%.
Wow.
Oh, God.
Are you going to run Occam's razor over that one and list off some of the assumptions that we need to make?
People are sick of hearing me talk about Occam's razor, but this is a more important topic than most to run Occam's razor over. So It's relatively common for natural mutations in the RNA or DNA of viruses to enable that jump between different species. Like, for example, the H1N1 pandemic in 2009 was known as the swine flu, and that's because the virus mutated the ability to infect humans from pigs. There are numerous other cases of virus jumping species. In fact, the technical term for that is called zoonotic transfer. And in fact, that's pretty much how all human viruses have ever evolved. So the prevailing theories, which were based on RNA analysis of SARS-CoV-2 and published in March 2020 in the journal Nature, is that this virus originated in one of the two scenarios as follows. I quote from the paper, "Two scenarios can plausibly explain the origin of SARS-CoV-2. 1. Natural selection in an animal host before zoonotic transfer, and 2. Natural selection in humans following zoonotic transfer." So basically, it either evolved the ability to transmit to humans before it got into humans, or it got into humans and then evolved the ability to infect human cells.
Oh, okay.
But either way, it's a natural evolution.
Right. And this has been observed in nature with a lot of different viruses.
Nearly every human virus ever it has one of these two methods. So this study was unable to definitively identify enough of a similarity to a known animal coronavirus to say definitely what animal it came from, though it was very similar to those found in the Rhinolophus affinis bat and the Manus javanica pangolin. But they note that, understandably, the diversity of coronaviruses in animals is massively undersampled, because why would we go out to every animal, sample all of these animals, take them to a lab and analyze every virus that we find? There's just so many millions of viruses that's unfeasible.
Mm-hmm. So a pangolin is like an anteater type creature, isn't it?
Yeah, it's like that scale. It's got the big, thick scales, and it's illegally traded in Chinese markets a lot. And for some reason, people decided that it would be a good scapegoat. A bat or a pangolin would be a good scapegoat. And this paper tested those coronaviruses that were known to be found in those species. And there are some similarities, but like I said, there's no definitive answer as to what animal it came from and how. Regarding the second theory of origin, as in it was made in a lab and released accidentally or intentionally, the study has the following to say. It is improbable that SARS-CoV-2 emerged through laboratory manipulation of a related SARS-CoV-like coronavirus. The genetic data irrefutably show that SARS-CoV-2 is not derived from any previously used virus backbone. End quote. As you alluded to earlier, Levi, we are going to be using Occam's razor, and I'm sorry if people are sick of me going on about it, but it's extremely important. The explanation that requires the fewest assumptions is usually the best one. If nearly every known virus to infect humans throughout history has naturally evolved the ability to do so from contact with animals, there's absolutely no reason to assume that the consumption of a bat was necessarily the cause here, and there's even less reason to assume that this new coronavirus that shares a number of characteristics with other known coronaviruses was somehow synthesized in a lab using never-before-seen methods, and to suggest this is unhelpful and downright harmful to public understanding of virology in the future and at the moment.
The other big conspiracy theory at the moment is the 5G one,
Well,
which there's 4 different derivations of it, of like what it actually has to do with 5G, and it's very confusing.
do you want to run over a couple of? I'm conscious that we've already done an episode on 5G and how it doesn't cause cancer and is actually not harmful in any way, shape, or form. And many of those arguments actually apply to this particular argument as well. So if anyone's interested in 5G, then they should go and look at our episode on 5G and why it doesn't cause you any significant health problems.
Just quickly, because I'm not really familiar with too many of the 5G conspiracies, is there a school of thought that's suggesting that the symptoms that we're experiencing if you have this coronavirus aren't caused by a virus, but in fact caused by 5G?
Yeah, so I think a couple of theories. I think one is that the 5G network actually causes it.
I'm just gonna Occam's razor.
Yeah.
Yeah. Yeah, there's so many assumptions that you need to make, basically, for all of these conspiracy theories, isn't there?
Yeah.
I mean, it's so simple. The answer is so simple. It's a naturally mutated virus that originated in animals and mutated the ability to transfer to humans, like every other virus ever. That requires no assumptions that require new knowledge.
Yeah, exactly.
Oh, here's the other one. Quarantine has facilitated an unobstructed 5G rollout and has ended the ability for mass public protests against 5G.
I guess the people who died of the virus are just actors or something.
No, just collateral damage, mate.
Yeah.
I heard that the government created it so that we all have to stay inside so that they can replace the batteries in the birds.
What? You're just making that up, surely.
I mean, that makes as much sense as anything.
Yeah. Why not spread that?
Got to replace those bird batteries, and that's the only way to do it.
That's a more fun conspiracy than anything else that I've heard.
Anyway, sorry, Matt, to run off with a bit of ridiculousness. You may continue.
No, that's okay. I mean, there are people who take that seriously, so I'm not sure we should be talking about it so flippantly, but it's obviously ridiculous. And for more information about why 5G is completely harmless, go and see our previous episode.
And the other one, unsurprisingly, is anti-vaxxers jumping onto it as well.
Well, it's completely threatening to their entire belief system because the only way we're going to really be free of this coronavirus is with a vaccine.
Yeah.
I would love to hear the opinion of somebody of some staunch anti-vaxxers. And I was talking with somebody the other day.
I wouldn't.
Saying what we should do, I suppose one of two things. Before anyone's allowed to get the vaccination when it finally comes out, there should be a screening of your social media to work out whether you've ever shared any anti-vax propaganda. And if you have, then sorry, step out of the line, please. Or the other one is to include the MMR vaccine in with the coronavirus vaccine.
No, that'll feed into it. That'll make it worse.
That'll just start conspiracy theories about how we've engineered this virus so that we can introduce the mind control vaccine to everybody.
Yeah.
It seems bizarre in the current global environment. It seems ridiculous to even consider being anti-vaccination. But anyway, this is all beside the point because what I really wanted to talk about, what really gets up my nose lately is the PPE and how we use it in public. So Sam, do you want to run over the ways that SARS-CoV-2 are able to infect other humans? So once it's in your cells and it starts spreading in your respiratory cells and killing those off, then presumably once it kills its host or its host kills it, then it has no way of replicating. So it must have a way of getting to another host somehow.
Yeah, so it's essentially through aerosolized particles. So small particles in water droplets in the air that it gets transmitted by. So obviously for that to take place, you need to either have contact with an infectious person or something they've recently touched and left water particles there. So for COVID-19 specifically, one of the main concerns is there was a study mid-March in New England Journal of Medicine that showed the virus was actually detectable in aerosols for up to 3 hours, up to 4 hours on copper, up to 24 hours on cardboard, up to 2 to 3 days on plastic and steel surfaces. So that was quite concerning because that's quite a long time comparatively to other viruses. But there was some clarifying studies a bit later on that showed that, it was certainly detectable on those surfaces. It's not actually at an infectious level at that time. So it's quite similar in that it's still up to a few hours and up to a day on certain surfaces. It can still be at an infectious level. So this is the reason that we have the measures in place of social distancing. So if if someone who's infectious coughs or sneezes or otherwise aerosolizes particles, there's been plenty of studies in influenza and other viruses that have shown that it will spread to approximately 1.5 meters away from the sneeze or the cough, which is why we have the 1.5 meter distancing rule. So by that way, we're attempting to eliminate person-to-person transmission from coughing or sneezing. And then the second measure is hand hygiene, sanitizing surfaces. So basically, and there was the New Zealand Prime Minister actually said something a few weeks ago, which I thought was fantastic, which was the most effective way to prevent the spread is to act as if you are infectious. And if any surface you touch is contaminated. So if everyone was diligent enough, and obviously it's very, very difficult to be that diligent, but if everyone was diligent enough to stay more than 1.5 meters away from other people and sanitize every surface and wash their hands after touching any surface that could possibly be infected, then that would stop the spread.
Yeah, and that was a bit of a game changer for me, really, when I heard somebody say that don't go out in public as though you're trying to avoid it. Go out in public as though you already have it. And
that's right, yeah.
If you suddenly assumed that you had it, chances are you wouldn't leave your house at all for a couple of weeks. But
And you shouldn't unless you have to.
Exactly right. Yeah, that's the current advice, isn't it?
Yeah.
And it's good advice. In general, if you don't leave your house, then there's no way you can get exposed to other people who may or may not have the virus, and there's no way that other people will be exposed to you.
That's right. So that with that initial study, there was concern that it would be still in the air for up to 3 hours after someone had walked through, but that's actually not the case. It's the aerosolized particles are still present for hours, but the particles are found on surfaces, not still in the air. Yeah.
Yeah.
Which kind of brings up the interesting point around masks. And obviously that's one of the things that's been panic bought and hoarded.
Yeah, I wanted to talk about that a little bit as well because it bothers me particularly because my mum is a nurse, and in a hospital setting, when a nurse is dealing with an infectious patient, the patient is in a room with the door closed. The nurse has to go into the room and they wear the following clothing: either a single-use full face shield or wraparound eye protection, single-use gloves, a single-use facial mask, and a single-use gown of appropriate sleeve length. So do you notice a pattern with all of those items?
The single use.
Single use. So what you do when you go into the room, you don all of these items when you go into the room, and then you do what you need to do, then you remove them carefully in a specific order to minimize the contamination, and you sanitize your hands after you remove every single item.
Actually, sanitize your hand, 3 times during the procedure.
And then as soon as you leave the room, you do a comprehensive hand wash after you leave the room before you do anything else. So the best way that I have seen to visualize the way that viral transmission works is to imagine that anything contaminated is covered in bright blue paint. And there are several good demonstrations of this on YouTube that I'll link in the show notes. But basically, it means that whatever you touch that has paint on it is considered contaminated. So if you touch a contaminated surface, even if you have gloves on, and then you touch your eyes, you'll get paint in your eyes. If you touch a painted surface and then you touch another unpainted surface, you'll spread the paint to that surface. And then if you came back even with clean gloves on and you touch that surface that you spread paint to the first time, then you'll get paint on your hands again. The
reason that nurses and other health workers need to wear the masks and all that equipment is because they can't stay 1.5 meters away from an infectious person.
Exactly.
And they can't not have prolonged contact with them. So if you're having prolonged contact or you're within 1.5 meters, you need to be wearing that equipment. And the other issue obviously is, so when there's procedures that can generate aerosol particles, such as intubation, then if you're wearing respirator masks, such as the N95 mask, which is one of the ones that's been panic bought, and there is short supply.
And so mask is another good one, because if you're wearing a mask and your nose gets itchy, for example, and you use your hand, whether it's gloved or not, to move the mask, scratch your nose, then not only have you spread whatever was on your hands onto your nose, but having touched your mask and then your nose, you've spread whatever was on your mask to your nose as well. So by far the best possible thing that you can do to prevent the spread of any kind of infectious disease is to wash your hands thoroughly and often.
Yeah.
And the second best thing is to stay a safe distance away from an infectious, well, from everybody in general, but particularly an infectious person.
And in regards to wearing masks in the community, well, there haven't been specific studies for COVID-19 because there's not enough, hasn't been enough time to do them. But there have been plenty done on influenza, and they've basically shown there's no really significant reduction in influenza transmission if people are wearing them in the community.
Yeah.
There's also studies that have shown that people in households together with one person sick, they've had studies where they've had just the sick person wear them, no one wear them, or the whole house wear them, and there was no difference in the infection rate between members of the same household.
Because I suppose all that it's preventing is one person coughing directly into your mouth. Like everything else that spreads the virus, like you touching a surface and then touching your face, or touching a surface and then touching your food.
That's right. If you're staying the correct distance away and you're doing correct hand hygiene, then yeah.
The other thing is, if you have a mask on and someone coughs into your eye, that's still going to spread the disease.
Yeah, and the other issue is that they've found in similar studies that the compliance with the mask is actually very poor.
Yes.
And the way that you put them on and off is quite important because if you take it off incorrectly, you're actually going to aerosolize the particles anyway.
Yeah.
So you might have prevented them getting in, but then they're going to be on your mask.
Right.
And more often than not, wearing PPE in general gives you a false sense of security, and it can lead to complacency.
That's the other concern, yeah.
Also, depending on the type of face mask, the disposable ones that are used in hospitals, the moisture from your breath can actually make most of those permeable within an hour, which is why they're considered single use and they're disposed after every patient.
Yeah, and people tend to touch their face more to readjust the masks.
Exactly. And the more you touch your face, the more you can put so it's just, I'm not saying don't wear any PPE. There is very limited evidence that it may offer some level of protection, but there are shortages, like you said, of many types of medical PPE all over the world at the moment. And in the immortal words of Dr. Stephen Novella, whom we all have a lot of time and respect for, he said, keep your distance from other people, don't go out, and if you have to, the masks help a little, but don't get a false sense of security from them.
Mm-hmm. Well, interestingly, and I'm sure the trouble with talking about COVID is everything changes so quickly, but the CDC in America is actually now recommending general population wears cloth masks in the community, basically because their feeling is, well, it doesn't have a whole lot of evidence showing that it will stop the spread, but what's the harm?
I guess, and if they're homemade cloth masks, then there isn't a harm. But if they're going out and buying N95 masks that
are then not going to hospitals and used by people who are in contact, that's harm.
Then that is a problem. Yeah.
So it's a difficult area, and there's lots of literature coming out about it at the moment. It's pretty interesting.
I think another indirect effect of the mask, wearing a mask in public, is that it's almost a good reminder to distance yourself from people. Like, for example, I had to go to a shop a couple of weeks ago, and there was somebody there that was wearing a mask. And whether or not that was actually doing anything for their health or mine, just seeing them with the mask made me assume they've got coronavirus. I'm going to avoid them. So I made sure that I stayed at least 6 feet away from them. I didn't touch any of the surfaces that they'd just touched. It was a good reminder, I suppose, about these social distancing and hand hygiene regulations.
Well, eventually we should get to the point that we don't need reminders because, like you said, Sam, if everyone could social distance perfectly and stop touching their faces and wash their hands all the time, disease wouldn't be able to spread. And the fact that we're fallible humans is the reason for the current restrictions.
That's right. But I think what we've done in Australia quite well is we've gone very early and active on isolating infected or possibly infected people. And that's what slowed our spread so much, is we don't have possibly infectious people out in the community. Because it's obviously the big difference. I'm sure people are aware by now, the difference between COVID and something such as the flu is that COVID has such a long incubation period and such a long time period where you can be infectious but be asymptomatic. It's up to 10 days, up to 14 days, whereas the flu is 1 to 4 days. So with influenza, generally, you're usually infectious from 1 day before symptoms to 7 days after onset. So you're not having this big long period of a week up to 2 weeks where you could be infectious without having any symptoms.
So part of the problem with SARS-CoV-2 as well is it's not very well understood because it hasn't been around for that long. The numbers are sporadic. Some countries are testing more people than others. Some have, shall we say, less than reliable reporting, and most of the time we physically don't have the resources, time or physical resources to test everybody. Ideally, we would be able to test everybody and get a really good handle on how deadly it is, how easily it's spread, and how many people actually have it. For that, we'd need a lot more time and resources that we have at the moment. We're able to study and understand things like influenza A because only changes slightly year to year, and it's been around for an extremely long time. So we've been able to do long-term studies on it, whereas SARS-CoV-2 has only been around for a number of months. And this is the reason that the information changes day to day. Literally, studies are being done at the moment to try and figure out where it came from, how long it's been around, how long it's likely to be around. Models are running at the moment to see how bad or how good the social distancing measures will be. There's a lot of new information coming to light, and I think the main point that I want to make before we shut up about COVID-19 is that we should be informed about it, but not alarmed. It is likely far worse than a regular flu, but there's no reason to panic. Social distancing is probably good practice all the time for the rest of your life. Regular thorough hand washing is probably good practice all the time for the rest of your life. If you do get COVID-19, it's much more likely that you will experience mild to intermediate symptoms and make a full recovery. However, it's hard to find some ground in between the utter media-induced panic and complete denial that it's a problem and that it's even existing, and get caught up in the arguments about whether or not it's been intentionally or accidentally released from a Chinese lab somewhere. However ridiculous that might be. But try and keep a cool head and base your decisions on evidence from experts directly.
The trouble is, because, as you're saying, because everything's changing so rapidly, all the studies coming out are not peer-reviewed because there's simply not time to review them. There's lots of interim studies and poor quality evidence coming around, which is where, such as the hydroxychloroquine and azithromycin treatment that was touted by a prominent world leader that it was a miracle cure and should be put into practice immediately, was very poorly tested in a horrendous quality study and has actually resulted in a couple of accidental deaths. So yeah, it's really important that you get information from trusted sources. And by trusted, I mean either peer-reviewed journals or government websites.
Yes, or the World Health Organization, which has just been defunded by the said prominent world leader. Anyway.
Who are we talking about?
The sort of thing I'm talking about on a more local basis is I saw a post the other day where someone had shared a post from a guy who was quoting their friend's uncle, who apparently worked at a Chinese hospital. It didn't say in what capacity they worked at a Chinese hospital, and he had a master's degree, but it didn't say what the degree was in. And it was filled with a whole bunch of misinformation about how the virus survives on surfaces and how to prevent it, with tips like don't drink ice water, make sure you always drink warm water because that kills the virus. So obviously that is pointless advice, and it's mixed in with some good advice and some terrible advice that makes it sound legitimate. Just make sure that you're getting your information from good sources, official sources. See, really, Trump really throws a spanner in the works here because he's an idiot. But think about your sources.
And maybe if you read something on Facebook or another social website or anywhere else, yeah, maybe Google it and maybe just check it against something else before you repost it or share it on.
Be careful about sharing anything with friends and family, even if it's verbal. Any information that's not founded on scientific evidence, now more than ever, is thoroughly unhelpful, and in most cases is actually actively harmful.
For sure. Can we have a quick conversation, and it's more just spitballing because I don't know if anybody knows the answer, about what the long game is or what the end game is really with this? So currently, as we sit, today it's the 15th of April, and there are just over 2 million coronavirus cases.
2 million cases with about a quarter of them having been closed, either recovered or dead.
That's right, yeah. And there's been around about 130,000 deaths worldwide. So in Australia in particular, our cases, we have slowed that exponential growth, and that slowed sort of mid to late March really. And we've been seeing less and less daily new cases. And there was a drop since around about sort of that 23rd, 24th of March with a couple of spike days. But really since then, our daily new cases has been falling. So I guess the point that I want to make is that the end game of this, the only way that we're going to come out of this pandemic is either with, I suppose, one of three things. It's with a vaccine. It's with herd immunity. So everybody getting it and either recovering or dying. And then the third step is that everybody isolates and for a few weeks, and this will allow the virus to die on all the surfaces that it's existing on out in public, and sick people in isolation will recover. So I suppose that's the only way that we're going to get out of this, isn't it? And what's the most likely one? Where do we go from here?
Oh, look, it's impossible to say, really. I think in Australia, we're a bit of a separate situation. We're one of the few countries that was fortunate enough to get early infections, but then not many early infections. So we put all the measures in place relative to our outbreak quite early. So I think measures here are going to be different to overseas. And I think it's a good thing, because we've managed to flatten the curve, as I'm sure everyone's heard. And a quick point on flattening the curve, which was a point I had discussed with someone yesterday. It's actually not trying to reduce the number of infections so much as spread them out over time.
So we don't overwhelm the health system.
That's right. We just don't. If everyone who was going to get infected all got infected in the same week or within the same month, we would not have the capacity to care for all of them. And that's the situation you're seeing in places like Italy. And
even more localized than that in cities like New York.
Yeah, that's right. Yeah. It's really difficult to say how it's going to go. I think the definitive will be a vaccine. And that's probably 12 months away at this stage. I think there'll be some sort of lifting of restrictions between now and then. I don't think that lifting of restrictions will include international travel, but I think if we continue on as we are for a little while longer, weeks to couple of months maybe, we should have a good handle on it. The concern is that because we've had such low infection rates, we don't have herd immunity yet. So the concern is if we lift restrictions too early, or if people, essentially the biggest concern is if people get sick of social isolation and stop following the guidelines, then we'll have a second wave, and the second wave tends to be worse than the first. So I think in Australia, everyone's done a great job, population and government included. I think everyone's done a great job in putting the things in place, and everyone in the population has done a great job, generally speaking, in following the guidelines, because you can see it in the slowing of the rates. I think we just have to keep continuing on and accept that it's going to be longer than we want it to be.
So life on Earth, I suppose, for everybody that's on Earth, can probably go back to normal once we have a vaccine, and that'll be in 12 to 18 months.
Hopefully. And the thing with the vaccine is they're thinking that it will be quite effective because, so influenza, we get seasonal illness, which is, there's a thought that this might be a seasonal illness as well. But the difference is that the virus has been quite stable over time. It hasn't really mutated. So a single vaccine should target it quite well and should eradicate it pretty well. Whereas the flu mutates so much that we keep getting different strains coming every season, which is why we keep getting such high rates of infection.
I think I tend to agree with pretty much everything you've said, Sam, but that's why you're Dr. Sam Laucirica. But
yeah, that's why.
Generally, I think that, like I said, good hand washing protocols and even social distancing to some degree is good practice for even when we have a vaccine and we get back to everyday life. Because the regular seasonal flu is not, forgive the expression, not something to be sneezed at. It kills a lot of people, and it's not a pleasant thing to have, even for a healthy person. So I think that it's prudent to observe appropriate social distancing and hand washing measures in your everyday life for the rest of your life.
Yeah, and maybe a positive to come out of this is we're probably going to have a pretty good flu season here in Australia because the vaccine's starting to be rolled out over the last couple of weeks, and the prediction is that there's going to be a higher adherence to the vaccine than most previous years, and that there's going to be lower infection rates. So, well,
that, and combined with the fact that nobody's allowed to see anybody else, so.
That's right. So, it's a tough time at the moment, but there'll certainly be some positives that will come out of it. And some of the, just from public health worker perspective, some of the changes to the public health system that have happened so quickly because of this have actually been really positive. We've moved a lot towards telehealth and seeing patients remotely if we can. We're moving more towards what's essential and maybe more efficient ways of doing our day-to-day things. And I think there's actually going to be some positives that will come out of it in the long term.
Yeah, for sure. So, I mean, we could talk about coronavirus and we could talk about this pandemic for several more hours. And in the interest of poor Matt, who's got to edit the thing, we should probably start to wrap it up. But I think that's the thing, because it's so rapidly evolving and because it's just about all we've all been talking about. There is so much information out there, but what's inherent with a lot of information is also a lot of misinformation. So just make sure that you're getting your information about coronavirus and PPE from the correct sources. As Matt said, the World Health Organization and Australian government websites is a good place to start. Don't listen to a mate who heard some good information about his uncle's friend who works in a hospital in China, because it's probably not always all that reliable.
And if you do hear that information, maybe double check it before you pass it on.
Mm-hmm.
Yeah, I can't do it all by myself. Rarely do I get this worked up about anything in particular, but it's really important.
Warranted
I've
in this
included
case.
some good skeptically minded articles in the show notes if you want some more information on anything that we've talked about today. But in the meantime, from us at IdeoFacto, I would say stay safe, wash your hands, and I don't know, learn something new in your isolation if you want.
Alright guys, that's it for this episode of IdeoFacto. Thanks very much for having me, boys. It's been an absolute pleasure.
You're very welcome, Dr. Sam Laucirica. You can forward all suggestions, hate mail, evidence and arguments to idiofacto@gmail.com. But if you hated Sam, just lay off a little bit, okay?
Nah, I want the feedback.
You can also send PPE suggestions to any of our socials, Facebook, Instagram and Twitter, by searching at IdeoFacto. And all the links, as usual, will be in the show notes.
Very important this week.
And most of mine will probably be videos, and Matt's will probably be all peer-reviewed journal articles. But,
It's very important this week. You need some good information, so check it out. Right.
Don't include that bit.
Okay, I won't.
Please don't include that bit. It's so wacky.
What?
All I'll do is include the bit of us explaining that I'm not going to include that bit, so everyone can wonder, why? What did they cut out?
Please do that, actually.
Just bleep the whole conversation. and then
Just bleep every fourth or fifth word.
and then say, no, I'm not. I'm going to cut that part out.
We'll cut that out.
You'll get disbarred for that? Do you get disbarred?
I'm not a lawyer.
No, I know. Okay, yeah, you can't get disbarred, can you?
No.
From the bar.
Deregistered, I think it would be.
Deregistered, yeah, that's better.